Hi everyone, welcome to the session. Today we will continue with the modern periodic table. Okay, so who proposed this modern periodic table? Moseley. Okay, modern periodic table. Who proposed this? Henry Moseley was proposed modern periodic table. So in which year? 1913. So in 1913, the English physicist Henry Moseley observed regularities in the characteristic X-ray spectra of these elements. So based on these regularities, he said that the properties are generally based on atomic number, not atomic weight, and he taken into consideration of atomic number. Okay, till Moseley, all the scientists are classified the elements based on their atomic weight. But Moseley, what he has did, he has taken atomic number to classify the elements. This is one of the best achievement of this periodic table. So nowadays also we are using only this periodic table. So that's why this is called modern periodic table. And this periodic table is also called as long form of periodic table. What about the Mendeleev's periodic table? Mendeleev's periodic table is known as short form of periodic table, but here modern periodic table is called as long form of periodic table. So here what he did, first he observed regularities in the characteristic X-ray spectra of the elements, and atomic number Z can be related to frequency of that X-ray emitted by using the formula square root of nu is equals to V equals to A into Z minus B. See here, this is the frequency. Frequency is equals to square root of frequency is equals to A into Z minus B. So atomic number can be related to the frequency of that X-ray which is emitted. The X-ray which is emitted by using this formula. Here what about A and B? A and B are the constant values, and what is Z? Z is the atomic number, and here nu is the frequency. So he related this frequency and atomic number. Next, so here he plotted graph between these, and after plotting this he observed a regular pattern. So what is that? So he has taken atomic number on x-axis and square root of X-ray frequency on y-axis, x and y-axis, and if he plot a graph, he got a straight line like this. Okay, next, square root of X-ray frequency and its atomic weight. Here previously has taken atomic number, now he has taken atomic weight, and he got the result like this. So he got a curved line. So based on this, what we can say that, so when he has taken into consideration of atomic number, he observed a regular pattern, straight line, a regular pattern. But whenever he taken into consideration of atomic weight, how he got the plot? Like this. Okay, so it is not showing the regular pattern. So that's why he thought that instead of atomic weight, if we consider atomic number, that should be good for to classify the elements. Okay, so by this he concluded that atomic number is a fundamental property of an element than its atomic weight. Why? Because when he taken into consideration of atomic weight, there is no regular pattern in that properties, but when he taken into consideration of atomic number, he got a straight line. So the atomic number is a fundamental property of an element than its atomic weight. Next, so what is modern periodic law here? The physical and chemical properties of the elements are periodic functions of their atomic number. So here till now all the scientists are based on their atomic weights. but here mostly taken into consideration of atomic number. So here if we know the atomic number, we know the number of electrons. Already we learnt in the previous chapter, that is atomic number is equals to number of protons, that is equals to number of electrons. If they have the same number of electrons, or based on that number of electrons we are writing electronic configuration. So we can take into consideration of any one, either atomic number or electronic configuration. So whenever taken into consideration of atomic number and arranged in the increasing order, the physical and chemical properties of those elements are repeated. Okay, so those physical and chemical properties are the periodic functions of their atomic numbers and electronic configurations. This is the long form of periodic table. So here if you clearly observe, again here mostly also not given a proper place to the hydrogen, it is at the top, and here from lithium to neon, sodium to argon, potassium to krypton, like this all the elements are arranged in this. Same like Mendeleev's periodic table, here also we are having vertical columns. So these vertical columns are called groups. Okay, so vertical columns are called groups. Then what about the horizontal rows? Horizontal rows are called, here the first one we have the hydrogen and helium, and this is the second one. So horizontal rows are called periods and vertical columns are called groups. Tell me how many groups are there? 18 groups. And how many periods it has? 7 periods. Once check. 1, 2, 3, 4, 5, 6, 7. 7 periods. How many groups? 18 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 groups and 7 periods. Periods means horizontal rows, vertical columns, and what are the groups? Horizontal rows. Okay. Next, so it consists of 7 periods. So periods means horizontal rows. Okay, so the horizontal rows are called periods. How many periods are there? 7 periods. Horizontal rows are called periods. There are 7 periods. Next, vertical columns are called groups. How many groups it has? 18 groups. 18 groups it has. So now the older notation, how these groups are represented in older days. Okay, so the older notation of groups are 1A, 2A. First two groups are 1A, 2A. Roman letter 1, alphabet A. 1A, 2A. And here 3A, 4A, 5A, 6A, 7A. Look at here, Roman letter 1, A, 2A, 3A, 4, 5, 6, 7. Okay, next, after that here we have the, actually it is also called 8th A. 8th A are 0. After 8th A again starts from 1B. Okay, so here 1B, 2B. Next, 3rd B, 4th B, 5th B, 6th B, 7th B. 8th B elements are divided into 3 subgroups. 8th, this one is of 8th. 8th B is having 3 groups. Okay, next, here lanthanides. These groups are called actually lanthanides, from cerium to lutetium, where they are in between here, this lanthanum and hafnium. Okay, after 57, 58 will come. So 58 to lutetium 71. Here the 14 elements should come here, and those 14 elements are having almost similar properties, but here these 14 elements is not able to right in between lanthanum and hafnium. If they arrange that 14 elements in between that, the looking of this periodic table will not be properly. So that's why they taken these 14 elements and arranged at the bottom. But here these are even though they are arranged at the bottom, this is not separate period elements. They belongs to which period? Only 6th period. Okay, lanthanoids are belongs to 6th period. Those elements will come after lanthanum, before hafnium. Okay, and what about this thorium to lawrencium, that is from atomic number 90 to 103, they will come here. Okay, here only. So that means they are belongs to 7th period. So here these groups are represented with 3rd B to 2nd B. That means these elements are present between 3rd B and 4B. These elements are present between 3rd B and 4th B. Okay, so these are the older representations. Is it good to remember, easy to remember? 1B, 2B, 1A, 2A, 3A, 4A. Okay, and that too, these are not in the order. See, 1B, 2B is here, 3rd B to 7th B here, and again 3rd B is divided into 3 groups. So that's why what they did nowadays, IUPSC given some other recommendations. Okay, so IUPSC, what is meant by IUPSC? International Union of Pure and Applied Chemistry. This is a group of members which are taken to the decisions and given the rules time to time to give the clarity on the names as well as the atomic numbers as well as these group numbers. Okay, so they will take the decisions about the elements and they will give the clarities. Okay, so the groups are numbered 1 to 18 in accordance with IUPSC recommendations. So here IUPSC suggested that it is not possible to remember every time it is. That's why what they did to simplify this, they simply given from 1 to 18 numbers. Okay, so 1 to 18. Now no need to write Roman letter, no need to write the alphabet. Simply give the number 1 to 18 to groups continuously. Okay, see like this. So 1, 2. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again starts from 13, 14, 15, 16, 17, 18. So 1A, 2A is equals to 1, 2. 13 is equals to 3rd A, 4th A will be equals to 14, 5th A 15, 6th A 16, 7th A 17. Okay, 0 group is equals to 18. So now this is the easy to remember the group numbers. Okay, don't confuse here. Actually in the most of the cases we will use these elements 1A, 2nd A. Okay, so 1A, 2A elements are first and second groups. Next, these elements, those are from 3rd A to 0. So 3rd A is called 13, 4th A 14, 5th A 15. So like this you should remember these group numbers. Okay. So make a note that period number. So which are called periods? Horizontal rows are called periods. How many periods are there? 7 periods. So just remember a point. Its period number gives highest principal quantum number of that element in the period. So whenever we are writing periodic whenever we are writing electronic configuration, whenever we are writing electronic configuration, we are using principal quantum number, azimuthal quantum number and writing the configuration, right? So in that, the last electron entered into one principal quantum number. So based on that principal quantum number, we can say that to which period it belongs. Okay, so period number is equals to highest principal quantum number. That means the shell to which the last degenerate electron enters, the last differentiating electron enters, or the orbit to which the last electron entered is called highest principal quantum number. Okay, for example, if we take the sodium, everyone knows the atomic number of sodium, right? What is atomic number? Sodium 1s2, 2s2, 2p6, 3s, 2 plus 2, 4, 4 plus 6, 10. So how many electrons are remaining? Only 1. So that's why we should write 3s1. So now which one is the last electron? This one. So last electron entered into which main shell, which orbit? Third orbit. That indicates principal quantum number. So here in all these 1, 2, 3, which is the highest principal quantum number? 3. So now this element belongs to third period. So period number is equals to highest principal quantum number, right? So here what is the highest quantum number? 3. It belongs to which period? Third period. First one, hydrogen will come here. So first period contains only 2 elements, hydrogen and helium. Later lithium to neon, now sodium. So it belongs to which period? Third period. I hope you understand now. Okay, so period number gives us the highest principal quantum number of that element in that period. Okay, next. What are the important points of this modern periodic table? We know that modern periodic table has groups and periods. How many groups it has? 18 groups. Which are called actually groups? The vertical columns are called groups. Okay, vertical columns are called groups and horizontal rows are called periods. How many periods it has? 7. Now, the first period of periodic table consists of how many elements? Only 2. What are those? Hydrogen, helium. Okay. Next, the remaining periods from 2nd to 6th consist of the different number of elements. Already we learned the maximum number of electrons in that shell is given by which formula? No. 2n square. So now we will check the period number will be equals to the quantum number, the last last principal quantum number. So here, for example, if you take the second shell, second period is equals to its quantum number, its last principal quantum number, right? So for example, now you take the n equals to 2. Now you substitute here, how much you will get? 2 into 2 square. So 2 square means 4 into 2, 8. So second shell contains 8 electrons, right? So that's why second period will also consist of 8 electrons. So here, based on that we can calculate number of electrons, or simply you remember second, third, fourth, fifth, 6th. So first shell contains only 2 elements. Those are hydrogen to helium. So totally how many elements? 2 elements. Next, second period contains lithium to neon. How many elements? 8 elements. So second period consists only 8 elements. Next, third one, sodium to argon. How many elements it contains? 18. Sodium to argon, 18. Next, fourth one, potassium to krypton. How many elements? 18 elements were arranged. Next, fifth period, rubidium to xenon. How many elements? Again, sorry, it has only 8 elements. Sodium to argon, it has only 8 elements. Potassium to krypton, 18. Rubidium to xenon, 18. Next, sixth period, cesium to radon. How many elements? 32. Okay, so this is the number of elements in each period. Second period consists how many elements? 2. First period. Second period, 8. Third period is also 8. 8, 8. Next, fourth period 18, fifth period 18, sixth period 32. Okay, so here 2, 3, 4, 5, 6. Second period 8, third period 8, fourth period 18, fifth period 18, and sixth period 32 elements are present in that. Okay, so they consist of different number of elements respectively. Okay, next, important points of this. One more important point, the seventh period is actually, it was incomplete, but now they arranged the elements and they are trying to find out the complete properties of those. 14 elements of both 6th and 7th period are placed below the main body of the periodic table. So what are those elements? Lanthanoids and actinoids. Lanthanoid and actinoids. So 6th period elements are lanthanoids, 7th period elements are actinoids. So these lanthanoids and actinoids are placed below the periodic table, but we are not considering them as a separate periods. They are belongs to 6th and 7th only, but it is not possible to arrange in the periodic table, so that's why they arranged at the bottom. That is it. Next, first period. How many elements? 2. What are those? Hydrogen and helium. Next, second period, from lithium to neon. How many elements are there? So first one, hydrogen, helium, only 2 elements. Now check the second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So 1, 2, 3, 4, 5, 6, 7, 8. How many elements? 8 elements are there. So from lithium to neon. Next, third period, from sodium to argon. Count again the number of elements. 1, 2, 3, 4, 5, 6, 7, 8. So 2, 8, 8. Now fourth, from potassium, potassium, calcium, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, bromine, krypton. So totally 2 plus 6, 8. And in between how many are there? 10. So 10 plus 2, 12 plus 6. How many totally? 18. Okay. Next, rubidium to xenon. Here also how many elements are there? 18. 2 are from rubidium strontium and 10 electrons are from the transition state, that is in the green color. Next, from here to here, these are the 6 elements. So 6 plus 10, 16. 16 plus 2, 18. Okay. Next, 6th period. 2 and from here to here 10. 10 plus 2, 12. 12 plus 6, 18. But here in between lanthanum and hafnium, from 58 to 71, how many elements are there? 14 elements. These 14 elements are coming after lanthanum and they are having similar properties to lanthanum. That's why these 14 elements are called lanthanoids. So why they are calling lanthanoids? Why? Because they are coming after lanthanum and almost having similar properties with lanthanum. So that's why these are called lanthanoids. So here 2 plus 10, 12 plus 14. So 26 plus 6. So totally how many elements are there? 32. Okay. So next, seventh period. Seventh period. So seventh period contains the elements from francium to last 1/8 element. Okay. So again same, it has a 32 number of elements. But here after actinium to this element, again it has the 14 elements. Okay, so those elements are taken and arranged at the bottom. So those are called actinoids. Why they are called actinoids? Why? Because they are coming after actinium and they are having similar properties with actinium. So that's why these are called actinoids on behalf of this element name. Okay, actinoids. Those are called actinoids. So this is the long form of periodic table along with the periods. what is the difference in the approach between Mendeleev's periodic table and the modern periodic table? So what is the main difference here? First, Mendeleev's periodic table is taken into consideration of atomic weight, and mostly in the modern periodic table taken into consideration of atomic number. So the atomic weight is a periodic function to Mendeleev's. Okay, so he said that physical and chemical properties are the periodic functions of the atomic weight. But what Moseley said? Moseley said that the physical and chemical properties are the periodic functions of the atomic number. Okay, so this law is called modern periodic law. This law is called Mendeleev's periodic law. Question: which element do you think would have been named by Lawrence Berkeley Laboratory, Seaborg's group? So here first one, Lawrence Berkeley Laboratory. So here which element is named by Lawrence Berkeley Laboratory? Here based on the name of that element, Lawrencium, we can say that Lawrencium is named by Lawrence Berkeley Laboratory. So here what is the symbol of this Lawrencium? Lr. And what is the atomic number? 103. 103 atomic number of this Lawrencium, and this element is named by Lawrence Berkeley Laboratory. And which element is named by Seaborg's group? The element is Seaborgium. So Seaborgium is named by Seaborg's group, and the symbol is Sg and atomic number 106. So here based on that name we can remember the element. Okay, next if we look at some multiple choice questions, the period that contains only gaseous elements, which period contains only gaseous elements? First period, second period, third period, fourth period. So here asking only gaseous elements, only gaseous. So here if we look at the periodic table, how many periods are there? 7 periods. In that 7 periods, second period to seventh period contains all types of elements like solid, metal, solid, liquid and gases. But here only one period contains only gases, that is the first period. So first period contains which elements? We know that hydrogen and helium. Hydrogen is a gas, helium is also gas. So which period contains only gaseous elements? Hydrogen and helium. Next, so here hydrogen and helium, these two are the gases. Next, the period that includes all types of elements, all types means S block elements, P block elements, D block elements, F block elements, and metals, non-metals, metalloids. So which one is having all types of elements? First period, second period, sixth period, seventh period. So we know that first period contains only two elements, hydrogen and helium. Second period contains lithium, beryllium. Next boron to neon. But sixth period contains all elements like representative elements, transition elements, inner transition elements. We will learn about these elements in the next classes, but here you remember that all the sixth period contains all types of elements. See, look at this. Here sixth period. This is the sixth period. It contains all types of elements. Here S block elements. These two are S block, and here from here to here D blocks including lanthanum. In between lanthanum and hafnium we are getting lanthanoids, F block elements, and from here to here P block elements, right? So it contains all types of elements. Next, the longest and shortest periods. So which is the shortest period? First period. Why? Because it contains only two elements, hydrogen and helium. What about the longest? So actually if we compare 6th and 7th in the periodic table, both are having 32 elements. So here if we look at the first period, it contains only two elements, hydrogen and helium. So only two elements, that's why it is called shortest. Okay, next second period 8 elements, third period 8 elements, fourth period 18, fifth period also 18 elements, sixth period 32 elements, and seventh period, even though we are writing 32 elements in the periodic table, but some of the elements properties were not clearly defined, so that's why we are taking sixth period is a completely filled period, and it has how many elements? 32 elements. Maximum number of elements are present in sixth period, so that's why sixth period is called longest period of the periodic table, longest period of the periodic table. And which is the shortest period? First period. Why? Because it has only 2 elements. Okay, so here shortest is first one, longest is sixth one. So first is asking longest, so longest one is sixth period, and which is the shortest one? First one. So that's why the answer is sixth and 1. Here don't confuse and don't give the option first. Why? Because 1 and 6. But what is the first? He is asking longest. First we should write longest period. So which is the longest period? Sixth. So that's why we should write first 6. Later shortest 1. So 6 and 1. So sixth and 1. Okay. So this is the sixth period. It has 32 elements. It has 32 elements and it has only 2 elements. Okay. Atomic number of nitrogen is 7. The atomic number of the third number in the same family. So here, how to calculate atomic numbers? Simply, I will tell you one trick to remember the atomic numbers of the different elements in each group if you know the first element. Okay. So for example, what he is asking, atomic number of nitrogen is 7. Okay, and the atomic number of the third number in the same family. So where will be the nitrogen in the periodic table? First tell me. So here hydrogen and second helium will come. Next lithium, beryllium. Here boron, carbon, nitrogen. Here we are getting the nitrogen, second period. Okay, so second period. Nitrogen, oxygen, fluorine, below neon, below helium we will getting the neon. We are getting neon. So now what he is asking, below the nitrogen, atomic number of the third element. So here X and Y. So this will be the third element. First, second, third. Atomic number of the third member in the same family. So in the same family, which is the first element? Nitrogen. Second element? X. Now he is asking third element, Y atomic number. So we know that what is the number of elements in the first period? 2. Second period? 8. Third period? 8. Fourth period? 18. Fifth period? 18. Sixth period? 32. Okay, now what we need to find out? Atomic number. How to find out? First, so here in nitrogen is present in which period? Second period. So second period contain maximum how many elements? Second period contains maximum 8 elements. 8 elements. Okay, so now you just take the nitrogen atomic number 7 and add plus 8. So how much we will get? 15. So this 15 is the atomic number of this X. Okay, next in this third period how many elements again? 8 elements. So now again add 8 to that. So how much you will get? 23. So how much you will get? 23. But here after this how many electrons you will get? 18. So add plus 10, 18. So add 18 to this 15. 18. So 15 plus 18. How much you will get? 33. So here what is the atomic number of this Y? 33. Okay. So here to remember this, just do one thing, that is first we will take noble gases. Okay. Otherwise take the first group elements. first group elements. What are the first group elements? Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So it is not possible to remember atomic number of these elements, right? So first take hydrogen atomic number. Everyone knows hydrogen atomic number, that is 1, right? So now how to find out atomic numbers of other elements in this group? So now first hydrogen, and in the first period how many elements are there? Only 2 elements. So that's why now add to this. So how much we will get? 3. So that will become, now that 3 is the atomic number of this element. So now what is the atomic number of lithium? 3. Now in the second period how many elements will come? 8 elements. Add 8. So 3 plus 8, 11. So what is the atomic number of sodium? 11. Is it correct? Yes. Next 11. Again in the third period, this is the first period, second period, third period, fourth, 5th, 6th, 7th. So again in the third period 8 elements. Add 8. So how much we are getting? We are getting 19. So atomic number of potassium 19. So write 19. And fourth period how many elements? 18. So add 18. So 19 plus 18 how much? 37. So 37 you will get 37. Again in the fourth period, in the fifth period also how many elements are there? 18. Now add 18. How much you will get? 55. 55, not 65, it is 55. Okay. So next 55. So now sixth period 32 elements. So how much you will get? 87. So this is the way to calculate atomic numbers. Okay, so we have to know first element in that family and which period it belongs to. Okay, so here if we take the nitrogen belongs to second period. So he is asking third member in the family. So first we know that atomic number of nitrogen is 7, and in the third period we have the 8 elements. So that's why you add 7 plus 8. How much you will get? 15. Next, so this is the third period, first, second, third, fourth period. We know that fourth period contains how many elements? 18 elements. So add 18. 18. So how much you will get? 33. Okay. So now what is the atomic number of this element? 33. Next, for the next element, again you add plus 13. So how much you will get? 51. So the next element's atomic number 15. So like this you need to add atomic numbers. You need to find atomic numbers. Okay. So 23, 15, 33, 51. How much? 33. So if you look at the periodic table you will get it. Okay. Nitrogen 7. If you add plus 8 you will get 15. If you add plus 18, 33. If you add again plus 18, 51. Plus 32 you will get 83. Okay, so this is the way. Next, so these are the few important multiple choice questions based on modern periodic table. Okay.